Hi everybody. In this video I'm going to talk to you about how to calculate the IP range of a given network. Basically I've already written the program, as you can see here, and let's talk a little bit about this program. As you can see here, I've created this program using OOP, or object-oriented programming, so we can go ahead and import it as a module. So from the ipcalc file, we are going to import the ipcalc method, and ipcalc takes one argument, which is the CIDR network.append. Okay, basically I've done a mistake here. So as you can see here, the ipcalc has calculated the network ID, the net mask, the broadcast first IP, and the last IP. So let's take an example here. Let's say 8.15.16.1/22, for example, and let's go to a very powerful website here, and let's do 8.15.19. This is a very awesome program, IP calculator. So we are going to perform to calculate this range. The IP is 1. Okay, is 1, doesn't matter. So as you can see here, the address is as follows. The net mask is as we have calculated on our program, and the network is, as you can see here, 0.16.0, and the first IP, as you can see here, the broadcast IP is the same, and the last IP is as follows. So we should be okay. We're doing a nice job. So let's go to ipcalc here and take a look on how did I create this program. So first of all, we need to calculate the net mask. Basically, the net mask is pretty easy to be calculated. So just we need to understand some stuff here. So we already know that 1 byte is 8 bits, isn't it? And for a given net mask, as you can see here, we already know that all the left bits of that net mask are set to 1. As you can see here, this is our net mask. So based on the CIDR, which is 24 here, 24, actually we can go ahead and take the CIDR, which is 24, and create 24 bits here, set to 1, and the others are set to 0. Okay, so once we see here 22, we know that on the left side of the net mask, we have 22 bits are set to 1. Okay, excellent. So now we need to find a way how to iterate. We are going to initialize a list here, which is here as mask, and we need to find a way to how to fill in this given list with the net mask, with the given net mask, and we are going to iterate through each byte, and 8 times, of course, because each byte is 8 bits, if you remember. And we are going to go ahead and for the first bit is 128, the second bit is 64, so these two values would be added to each other. So this we would evaluate basically to 192, and plus 32 plus 16 plus 8, as you can see here. So now we have to generate these values as well as iterate 8 times for each single byte here, for each single element of the mask list. In order to do so, we are going to make use of this particular CIDR, because so let's do that. Let me open up a Python terminal. So as you can see here, let's go open up gedit here, and for I in range, actually 24, we can go ahead and print out I multiplied by 8. Okay, so as you can see here, now this particular instruction using this particular instruction, we would make sure that we are working 8 times, we are looping 8 times through the first element and 8 times through the second element, and so on and so forth. Okay, so as you can see here, we have 8 zeros, which is the first index, and 8 ones and 8 twos. Okay, from 0 to 7. Now we need to actually go go ahead and iterate through each one and do an adding. We are going to add this value because the first one is 128, the second one is 64, and so on and so forth. So in order to do so, we are going to perform some bit shifting operation. So basically, as you can see here, this particular instruction here would do the magic for us. So basically, we're going to start with 1, 0, 0, 0, 0, 0, 1, and what we are going to do is to do a bit shifting to the left. Okay, so first of all, the bit shifting would be 7, because 7 minus 0 is 7. 7 modulus 8 is 7. Okay, so if we do bit shifting 7 to the left, this one would be here, and this would be 0, which is 128. The second one would be 7 minus 1, which is 6, modulo 8, which is 6. Okay, and this would be as follows, which is 64, and so on and so forth. So the same things applied here. So if we go ahead to Python and so for I in range of 24, as you can see, guys, for I in range, I am so sorry, and we're going to copy paste this. We're going to print it out. So as you can see here, we are generating these values, okay, the same values. So once we are iterating through each byte, so as you can see here, this is 255, this is 255, and this is 255, because this is related to the first index. If you remember, on the left, on this particular instruction, the index is 0 here, from 128 to 1, so on and so forth. So now we are able to generate the net mask. Okay, and the last one would remain 0. Okay, excellent. Now in order to calculate the network is pretty much easy to calculate. It's actually easy to calculate the net mask or the network ID. What we need to do is to do an ending operation between the address and the net mask. Okay, so as you can see here, if we end the address with the net mask, we got this particular value, the network ID. Okay, well, the broadcast address is a little bit difficult to be calculated, so let's take a look on this website. So as you can see here, first of all, we need to calculate. I'm going to use the wildcard method, and in order to, what is a wildcard? A wildcard is the inverted net mask. So we have to invert all the available bits of the net mask, and in order to do so, we are going to use the operator under Python, the tilde, and this actually, as you can see here, the binary one's complement operator is unary and has the effect of flipping bits. So it will flip all the available bits, but as you can see here, this would give us a signed number, so we are going to end it with 0xFF to make it unsigned. So this is what I'm doing here, the tilde against the mask, and the mask is 255. The first element is 255, and this 255 when I is 0 and when I is 1. Here, this is the element. When I is 2, this is the element. When I is 3, this is the element. So we have the reverse, and what we need to do basically is to end the network ID, or the network ID, yes, the network ID, each element of the network ID, because here we are returning a list, as you can see here, we are going to sort it with the reverse. Okay, so as you can see here, this is not my I've took this idea from this website. As you can see here, we are going to perform a binary sort operation here to get the broadcast address, and we are going to return the broadcast address. The first address is a little bit strange, and the last address is a little as well. So basically, in order to calculate the last address, what we are going to do is to actually take the last element of the, let me show you here what I'm doing here. So the broadcast address is as follows. Basically the last address is the same, but we are going to eliminate to invert this bit from 1 to 0. Okay, in order to do so, we are going to end it with 0x fe, which is actually ff minus 1, 0x ff minus 1. Okay, so now we are going to return the last address. And if you want to, let me show you how to do that. So let's assume that the last address, the broadcast address, was 53 255, for example, or 53. Let's make it 55. If we end it with 0xff, we got 255. If we do minus 1, as you can see here, 254. Okay, because f minus 1 is e. Okay, and the same thing applies on how to calculate the first address. So now I've created the function here, and we are going to check if the slashes exist on the IP mask. We're going to take the address and the CIDR, pass them to the IP range class, and generate this given this output. And what I'm doing here, guys, for the as you can see here, the join method, as you can see here, we are returning, each method returns a list, for example, list with numbers, for example here. If we do join, for example, dots, we're going to join, for example, each element, we're going to join I for I in L. As you can see here, this accepts only strings. Okay, strings. So in order to do so, we have to convert str I to string, and that's the output. We have joined each element of the tuple with one of the list. I'm sorry. So that's our program. So you can go ahead and Python from ipcalc import ipcalc and ipcalc pass the any IP here slash, for example, 27, and as you can see here, we have our little output. So thank you for viewing this video. See you next time.